Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basavakalyan. The 48th session of Graph Theory 2, the topic is Fundamental Definitions in Digraphs. Already in the previous sessions, we have discussed what is the digraph and some kinds of sub-digraphs we have discussed. So today we will see what are the fundamental definitions in digraphs. So where we have got in the undirected graph the vertices, edges, the degree of the vertices, sum of the degrees of the vertices, like that what we have studied in case of undirected graphs. Similarly, we are going to discuss the fundamental ideas in digraphs also, but meaning or the idea is entirely different from as that of the undirected graphs. Okay, so what are those? We will see one by one. Let me consider first incident out and incident into edge. Very interesting ideas. Incident out and incident into edge. Okay, for example, directly we will consider this diagram. Okay, you just observe this diagram. Okay, in figure 1, the edge A1. So this is the edge A1. Yes, edge A1. So the direction is towards A to D. Okay, so edge A1 is incident out of a vertex A. This is very interesting. The edge A1 is incident out of a vertex A and incident into a vertex D. So the edge is towards is from A to B, A to D, A to D. So this edge A1 is said to be incident out of a vertex A and it is incident into a vertex D. For example, if I consider the edge, I think let me enlarge this. Okay. A4, if I consider the edge A4, see the direction, that is very important. So the edge A4 is incident out of the vertex D and it is incident into the vertex B. Is it clear? Similarly, if I ask you to say about the edge A7, okay, A7, the direction is towards C to B. So what you can say, the edge A7 is incident out of the vertex C and incident into the vertex B. Is it clear? So if I say an edge E equal to UV, then what you will say, the edge E is incident out of the vertex U and incident into the vertex V if E equal to UV is an edge or is an arc of the digraph D. So once again let me recall, an edge A1 is incident out of a vertex A and it is incident into a vertex D in this example. Okay, so it is clear when we will say incident out and when we will say incident into. Okay, so A1 is an edge from A to D. So that's why we used to say A1 is an edge which is incident out of a vertex A and it is incident into a vertex D. So this is about the idea of incident out and incident into edge. Okay, so now we will see what is the initial vertex and the terminal vertex. Okay, initial vertex and terminal vertex. Let us consider the vertex VI, in which the edge EK is incident out of VI. We are considering a vertex VI in which the edge EK is incident out of VI is called the initial vertex of EK. Very simple. EK is an edge which is incident out of the vertex VI. So that's why VI is called the initial vertex of EK. Suppose the vertex VJ in which EK is incident into is called the terminal vertex of EK. Very simple. In the morning we are going from our house to college. So our house, that is initial point, initial vertex. we are reaching to college. So college is the terminal vertex. If you consider only one edge between house and college. Okay. House is incident to vertex and college is the terminal vertex. So in general, the vertex Vi. So suppose edge Ek. Ek is an edge which is Vi Vj and the direction is towards Vi to Vj. In that case, what we can say, the edge Ek is, the edge Vi is an initial vertex and the vertex Vj is a terminal vertex. So therefore, in this digraph, if I consider, okay, suppose A1 is an edge and it is from A to D. So what you can say, A is the initial vertex and D is the terminal vertex, because this edge A1 is incident out from A. So that's why it is called initial vertex, and the edge A1 is incident into a vertex D. That's why it is called a terminal vertex. So you can refer all the edges and the vertices, you will come to know. Okay, I think this concept is very clear. So what you mean by the initial vertex and the terminal vertex. So in figure 1, D is the initial vertex and B is the terminal vertex of the edge A4. One example, for example, A4, yes, A4. So if you see the direction, it is towards from D to B, A4. So therefore, A4 is incident out from D and A4 is incident into B. So that's why D is the initial vertex and B is the terminal vertex of this edge. Okay. I hope you have followed this idea. Now, what do you mean by out degree of a vertex and in a degree of a vertex? So that's the difference between the digraph and the graph which we have discussed earlier in the 3 sessions. There we have discussed what is the degree of a vertex. The number of edges incident with that vertex is called the degree of a vertex. Okay, but here simply we won't say degree of a vertex. We will see out degree of a vertex and in a degree of a vertex. So that is very interesting. Okay, what is that out degree and in degree we will see. The number of edges incident out of a vertex Vi is called the out degree of Vi and is written as D plus of Vi. Once again, the number of edges incident out of a vertex Vi is called the out degree of Vi and is written as D plus of Vi. Okay, what do you mean by in a degree of a vertex? So the number of edges incident into a vertex Vi. How many edges are incident? The number of edges incident into a vertex Vi is called the in degree of Vi and is written as D minus Vi. So here the lot of difference between the degree of a vertex in the ordinary graph, undirected graph and directed graph. Okay, so there the number of edges incident to a vertex, it is okay, that will be the degree of a vertex. Here the number of edges incident out will be the out degree of the vertex. The number of edges incident into a vertex is the in degree of a vertex. Okay, so that is the difference. So we have got 2 ideas on degree of a vertex. So simply we won't say degree of a vertex, we used to say out degree of a vertex and in degree of a vertex. Let us consider this example once again. Let me consider the same graph which we have considered. Okay, so these are the vertices and edges. If you see A, if you see the vertex A, how many edges are incident out from the vertex A? That you have to count. So this is the only one edge. Which edge? It is A1, which is incident out of the vertex A. So that's why D plus of the vertex A, that is the out degree of a vertex A, is 1. Similarly, first we will find out the out degree. If you consider the vertex B, okay, B. So how many edges are incident out from the vertex B? So this is the one edge which is I think A3, and another one is A2. A2 and A3 are incident out from the vertex B. So that's why the out degree of the vertex B is 2. That is D plus of B is 2. So like that you can find out the degree of out degree of C. See how many edges are incident out from the vertex C is very important. If you see how many vertices are incident out, edges are incident out, this is one edge which is incident out from the vertex C. Which edge? A7 is incident out. Similarly, the loop, you can say it is incident out. Of course, it is reaching to C itself, but first it is incident out from the vertex C. So that's why the out degree of the vertex C is 1 plus another 1, 2. So that's why you can see here, okay, the degree, out degree of C is 2. Similarly, what would be the degree of D? If you see D, how many edges are incident out from D? There are 2 edges which are incident out from the vertex D. The edge A4, similarly the edge A5, they are incident out from the vertex D. So that's why, but this is not incident out. The edge A1 is not incident out, it is incident into. That is different, okay. First we are observing incident out edges from the vertex D. So 2 edges are incident out from the vertex D. So that's why the out degree of the vertex D is 2. Okay, so like that we got the out degree of every vertex. Similarly, if you want to find out the in degree, so consider the vertex A. How many vertices are incident into A? Means you are reaching to A. So how many edges are there? One is A2 is incident into, another one is A3 which is incident into A. So it implies 2 edges are incident into the vertex A. That's why the in degree, what you can say, in degree of a vertex A is 2. If you consider the vertex B, yes, here it is. How many edges are incident into the vertex B? This is one edge which is incident into. See the direction, that is very important. How about this edge? So you can see A4 and A7. A4 and A7 are incident into the vertex B. That's why the in degree of B is 2. So like that you can find out the in degree of C, D. Okay. After finding the out degree and in degree, if you observe, observation is very important. What you will get? If you add the out degree of all the vertices, in this example it is 7. Similarly, if you add the in degree of all the vertices, it is also 7. So that is very interesting observation. Okay. So the sum of the out degrees of all the vertices and the sum of the in degrees of all the vertices is equal here. So that is the observation. Okay. Now let me consider the other ideas. Isolated vertex. What do you mean by isolated vertex? A vertex in which in degree is 0 and out degree is also 0. In case of undirected graph, degree 0 means what you can say, no edge is incident. Similarly here also an isolated vertex is nothing but there is no edge which is incident out or incident into that vertex. Okay. So there is no edge which is incident into or incident out of the vertex. So that's why we used to say such vertex an isolated vertex. So a vertex in which the in degree is 0 and the out degree is 0. That is the sum of the degrees, out degree and in degree, is equal to 0. Okay. Addition of those two will be. Now we will see the pendant vertex. So what is the pendant vertex? A vertex in a digraph is a pendant vertex if the sum of the out degree and in degree is equal to 0. What it implies? It implies either one edge is incident out of the vertex or one edge is incident into the vertex. Either of the option, either of the two. Okay, either it is incident out or there is one edge which is incident into. If it is both incident out and incident into, the sum of the degrees will be 2. So therefore, either incident out or incident into. In that case, so that vertex will be a pendant vertex. So same as that of the ordinary graphs or without the directed graphs, what you can say, if the degree of a vertex is 0, then that vertex is called an isolated vertex. If the degree of a vertex is 1, then that vertex is called a pendant vertex. There in case of undirected graphs. But here we won't say simply the degree. We used to say the in degree, out degree. So that's why there is a difference, a slight difference between the undirected graphs and the directed graphs. Let me ask you the question: is there any isolated vertex in this graph, or is there any pendant vertex in this graph? If you see the table, yes, the sum of the out degree and in degree of every vertex, it is more than 1. So it implies in this graph there is no vertex which is isolated, or there is no any vertex which is a pendant vertex. So when it will be an isolated vertex, if the sum of the out degree and in degree, if it is equal to 0, then it is an isolated vertex. If sum of the out degree and in degree is equal to 1, then it will be a pendant vertex. Okay, so let me consider some other ideas. Okay, so parallel edges. Already we have discussed parallel edges in the first session, I think, but here we have given a definite definition type. Okay, so two directed edges are said to be parallel if they mapped onto the same ordered pair of vertices. So such arcs, you can say parallel arcs. Okay, or you can say parallel directed edges must also agree in the direction of their arrows. That is very important. Okay, for example, in the figure 1, the edges A2 and A3 are parallel edges. Let me consider here, if I consider this one, the edges A2 and A3, yes, A2 and A3 are called parallel edges because from B to A but towards same direction. So here these two edges are incident out from B, and these two edges are incident into a same vertex A. So that's why you can say these two edges are parallel edges. Okay. Now we will discuss some theorems. See, in case of undirected graph, the first fundamental theorem was sum of the degrees of all the vertices is equal to twice the number of edges. The sum of the degrees of all the vertices is equal to 2 times the number of edges. So that was the first fundamental theorem in case of undirected graphs. So don't get confused with the undirected graph and directed graph. Okay, so ideas are little bit different in case of directed graphs. So there we used to say only degree, here in degree, out degree. So okay, so that's why the first theorem is in any digraph, you may say G or D, doesn't matter. In any digraph G, the sum of all in degrees is equal to the sum of all out degrees. As I said in the previous example, just observe. You have observed the table. There, if you add all the out degrees and if you add all the in degrees, so we got out degree and in degree equal. Okay, so that is in terms of theorem. So based on the observations and generalizing the ideas only, we got the theorems. Okay, so this is how research continues. Okay, so in any digraph G, the sum of all in degrees is equal to the sum of all out degrees. Okay, how to prove the result? Each edge, if I consider any edge, It implies if I consider one edge, definitely it will be incident out from one vertex and it will be incident into some vertex. Okay, edge equal to UV. Edge equal to UV. Then that edge is either incident out from U. Okay, if it is out from U, it will be into V, isn't it? So it will be incident out from one vertex, incident into another vertex. It implies each edge gives a degree plus 1 and gives a degree minus 1. It implies, see the difference, d plus 1, it implies out degree of that vertex for which it is equal to UV. So the out degree of U is 1, the in degree of U is V is 1. Okay, so that's why an edge which is incident out, incident into two vertices. Okay, one it is incident out, two it is incident into. So for that reason, one edge contributes how much of degree? Plus 1, that is degree 1, that is out degree 1, and it gives in degree also 1. So that's why if you add these two degrees, the total degree is given by Q edges. Q edges, it is for the one edge, it is plus 1 minus 1. Similarly for Q edges, it will be plus Q and minus Q. Obviously, then if you add the sum of these two, summation of the d plus, summation of the d minus, d plus, d minus, obviously both will be same, E is equal to Q. Okay, so equal to Q. So you can refer the previous example. Here you can see Q, the sum of the out degree is equal to 7, the sum of the in degree is equal to 7, so both are equal. So what is the 7? 7 is the number of edges or arcs in the digraph D. You can see how many edges are there. Total if you count 1, 2, 3, 4, 5, 6, and this is also an edge. Loop is also considered as one edge. So 7 edges, isn't it? So this is how we can verify the result also. So we have verified. Let me consider some other ideas. So what is the first theorem? That is, the sum of the out degrees is equal to sum of the in degrees is equal to Q, the number of edges in the digraph D. Okay. Now what you mean by source and sink? Source and sink. A vertex with 0 in degree is called a source. A vertex with 0 in degree. So the in degree is 0 is called a source, and a vertex with 0 out degree is called a sink. Very interesting. So a vertex is said to be a source as well as a sink depending on the in degree and out degree. So here a vertex with 0 in degree is called a source, and a vertex with 0 out degree is called a sink. The digraphs with the source and sinks appear in many applications such as flow diagrams. Okay, so as far as the application part is concerned, so you can see such ideas are involved in flow diagrams. So let us have the basic concepts of digraphs, then we will think of the application part later on. Okay, so this is about the source and sink. Next we will think of undirected graph. Undirected, so it is similar to the previous one. An undirected graph obtained from a directed graph G. An undirected graph obtained from a directed graph G is called the undirected graph corresponding to G. What it implies, undirected graph, whether you are whether you are erasing the direction of the edges, that depends on the situation. Okay, so an undirected graph obtained from a directed graph G is called the undirected graph corresponding to G. Okay, now we will think of the orientation of undirected graph. Okay, what is the orientation of undirected graph? Given an undirected graph H, we got H from the digraph D. Okay, we can assign each edge of H some arbitrary direction. Okay, the resulting graph designated by is called an orientation of H. See, D is the digraph and H is obtained from D, which is an undirected graph. Then after that, some arbitrary direction is given to each edge of H. The resulting graph is called orientation of this undirected graph. Okay, so therefore a digraph associated with H. Okay, that will be the again a directed graph only. So that will be a directed graph associated with H. Right? Now isomorphic digraphs. Isomorphism, what we have studied there. Here also isomorphic digraphs. Two graphs are isomorphic if they have identical behavior in terms of graph properties. Okay, so there roughly speaking the location of the vertices and edges, that was the difference. Otherwise both are one and the same. Say for example in case of undirected graphs, if I consider a cycle, then its complement is again cycle. So what you can say, C and C5 and C5 bar, the complement of C5, both are isomorphic. So I just don't get confused with those graphs and the directed graphs, just comparison. Okay, two graphs are isomorphic if they have identical behavior in terms of graph properties. So that is very important. Okay, so overall, so what we have discussed in this session, we have discussed what is the incident out and incident into edge. Okay, incident out and incident into edge. Similarly, we have discussed the initial vertex and the terminal vertex. Then we have discussed what is the out degree and in degree of a vertex. Then we have discussed the isolated vertex, pendant vertex and parallel edges. After that, we have discussed about the source and sink. So after that, we have discussed the undirected graph and orientation of undirected graph. At last, we have discussed the isomorphic digraphs. Okay, so there will be a slight difference between the graphs which you have studied up to 3 units. Here, in case of directed graphs, the ideas are a little bit different. So please go through properly and try to understand the concept properly, then you will follow the results very easily. Okay, so these are the books for your reference. Okay, so with this we conclude this session. Thank you.